Hi, my name is Dani. I'm an engineer at SpaceComputer, and I'd like to provide a brief overview of OrbitPort, our component that serves, among other things, for communication with our tamper-proof orbital network. Among the multitude of SpaceComputer's interstellar and Earthbound missions is to reliably provide true randomness from our tamper-proof decentralized orbital network. In this brief presentation, I'll elaborate on the need as well as the underlying architecture currently being employed to achieve this mission. Entropy and random number generators are foundational to modern computing and security. High-quality entropy is essential for generating unpredictable numbers that have many use cases, including creating unpredictable encryption and decryption keys that serve a vast array of cryptographic schemes and serve, among other things, cryptocurrencies and digital wallets, reliably generating nonces and random challenges in security protocols such as TLS, SSL handshakes, VPNs, and two-factor authentication tokens, creating unique and unguessable session IDs for applications, generating salt values for password hashing, thus preventing attacks such as session hijacking, address space layout randomization, a security feature in operating systems that randomly arranges the positions of key data areas in a process's address space, making it much harder for an attacker to execute exploits due to memory locations becoming unpredictable. The effectiveness of ASLR is only as good as the quality and reliability of the underlying entropy. Video game mechanics also depend heavily on randomness when generating loot drops, calculating critical hits, constructing map layouts and item stats. Gambling and lotteries, both privately owned and government run, require random number generators to ensure that they are statistically unbiased and unpredictable. In science and finance, Monte Carlo simulations rely on randomness sampling to estimate numerical results. These are vital in financial modeling when calculating risk and value complex derivatives. In physics, engineering, and statistics, where quality entropy is used to model complex systems where a deterministic solution is intractable. In statistical sampling and research design, randomness is utilized when wishing to ensure that samples that are selected for a study are truly random and representative of a larger population, in order to eliminate any chance of bias. This is crucial in fields such as medical trials, social science, and opinion polling. And finally, in blockchain and decentralized applications, generating trustless randomness caters to smart contracts in areas such as NFT drops or selecting validators in certain proof-of-stake protocols. Since results are public and must be verifiable, achieving a secure, unpredictable on-chain RNG is a complex problem that requires advanced protocols that are almost always rooted in high-quality entropy sources. Cosmic radiation serves as a source of entropy and is harvested by satellites in order to derive true non-deterministic randomness in numeric form. This facilitates SpaceComputer to provide systems with CTRNGs, cosmic true random number generators. The component responsible for orchestrating this capability and communicating with our orbital network is called OrbitPort. And I will go into a high-level overview of its various components that enable this rather graceful process. The main component in OrbitPort is the gateway, which serves as the framework's generic core and is extended by an assortment of purpose-built plugins. The orbital plugin serves as our egress module that communicates with orbital service providers, primarily satellites. Now, space is constantly engulfed in what can be described as a sea of fluctuating radiation levels from many different sources, and this is constantly observed and harvested for the derivation of randomness. Cosmic randomness is made accessible by beacons that are essentially ledgers of blocks, each containing random values in addition to metadata that serves for observability and attestation. Beacon management is a concurrent elegant dance orchestrated by a beacon scheduler, which retrieves and persists data belonging to an array of beacons from a registry. The scheduler taps into the orbital plugin for fresh randomness and then uses a beacon builder to create the next block in the sequence for any of the given beacons. Some of the beacons are public, while others are privately owned and consumed as a service. Now, resiliency and consistency are paramount and of the utmost importance at SpaceComputer, and therefore the beacon plugin also employs a master seed plugin in order to mitigate incidents where orbital services become temporarily unavailable. The master seed plugin consists of an orchestrator, which regularly retrieves randomness from our orbital services and maintains a cache of these values persisted within the master seed vault. These values serve as sources for deriving further cosmic random values at high scale and with consistent availability. Now, while we do employ multiple different methods for exposing our cosmic randomness to consumers, one facet I'd like to reference here is our IPFS plugin. Our IPFS plugin communicates with SpaceComputer's self-hosted IPFS node. IPFS stands for Interplanetary File System and is essentially a worldwide decentralized network of nodes. Together, these nodes maintain a network of addresses that lead to content of any type. Addresses are constantly being created, discarded, and are communicated between nodes using Gossip Protocol with eventual consistency. Every block that we create is published to the network and receives its own new dedicated address. But then one would ask, how do we facilitate easy consumption of our random numbers? And the answer to that is that we employ IPNS, Interplanetary Namespace, which is a single, consistent address that is always updated to reference each beacon's latest block. The IPNS address is never changing, always available, and always updated. Our IPNS nodes then participate in the decentralized IPFS network and serve for publishing updating our beacon block addresses all around the world. Consumers, applications, and on-chain services can call and access our IPNS addresses and retrieve fresh randomness on demand. From a consumer's perspective, a beacon is a blockchain, and the block contains the ever-growing sequence number, a reference to the previous block, and obviously the coveted cosmic random numbers.